Hi, everybody. Feeling good? It was a good day yesterday? Yeah. All right, so we're really excited to be here. We're going to talk about lots of really fun topics, a little bit of controversial topics too. But my name is Guneet Bedi. I'm the Senior Vice President leading the Adreno US business. And I am really, really excited to have and welcome the panelists here. Justin, maybe you can introduce yourself and go next.
Sure. Yeah, so I'm Justin Mortimer with NXP based in Austin. I manage a team of marketers that really help bring our new secure connected edge products to market. So we do a lot of collaboration with partners in the industry. We work a lot with our distributors and work with a number of engineers and customers around the world to develop some pretty cool applications with our products.
Absolutely, welcome. And Marcelino?
Yes, hi, I'm Marcelino Gemelli. I'm responsible for business development at Bosch Sensortech. Bosch Sensortech is the part of Bosch that makes MEMS sensors, right? We're just down the road here in Sunnyvale. And our primary market, of course, are high volume consumer electronics, but we also deal with a wider industrial, smart home, and IoT market in general.
Nice, thank you for coming. Thank you for making the drive from like 10 minutes away, so we appreciate that. And then Vincent Arena from Avnet.
Thank you. Good morning and appreciate you having us here. I'm Vincent Arena. I'm with Avnet. We are a global technology distribution company. We're about 28 billion, so we're one of the larger ones in the world. And from our standpoint, it's a really exciting opportunity to be here at Sensors Converge. My responsibility is for the global sensor business, but we expand that into the entire electronics ecosystem and supply chain around it. So really looking forward to the conversation.
Absolutely, welcome guys. And I think all of you know Adreno, and from our perspective, we've really build a community around open source as well as hardware abstraction, and now we're taking this into the enterprise and pro world. And the last thing I'll say is I'm really excited here because it's not 108 degrees like it's in Austin. So it's nice to be nice and warm. So, but for the panel, I think one thing I'd love to get all your perspective is we see a lot of industrial trends today, or just industry, mega trends, where a lot of us have been struggling with talent shortage, workforce gap, with of course the famous component shortages, as well as I think some slowdown in demand, which we think is temporary. But I want to get your perspective, and maybe Justin, you can start. And what's top of mind for you? What are the big mega trends, or good and bads that you see today from NXP's perspective?
Yeah, I mean, I think one of the big trends that I see more and more is really around software, and how do you combine all these complex technologies that can really bring so much value to the market, but how do you and how do you bring all these things together into a system that can really bring some differentiated technology to market? So for me, it's maybe the trend in supply or availability, or those things are cyclical, and I think those will always go up and down over time. But to me, it's really kind of a consistent need to have more extremely talented software engineers, and then how do you then also take software engineers from around the world? Because the industry is also changing, as you all know. It's not just a team sitting together in Austin or San Jose or anywhere around the world, but how do you take software engineers from around the world and work as a virtual team? And I think during COVID, there was a big effort to bring people together and to connect different teams in new ways. So for me, I think that trend is going to continue, and I think that's going to be a powerful force going forward, is having a more united software development team to really develop some cool stuff.
If you don't mind, before we go to Marcelino, maybe give us, because you're coming from a broad perspective. Of course, you all do MCUs and lots of other hardware solutions. Maybe give an example of how you've embraced that software movement, or where do you see that the global and the software movement come in?
So just to put it in perspective, I don't have the full numbers, but we have more software. We build microcontrollers. We're part of what was previously Motorola and Freescale and NXP, and now we're building connectivity MCUs and MPUs, secure elements, and so on. We have a significant workforce of software engineers to help make it easier for you and our customers to build solutions. And I think it's about making the products that we build easier to more rapidly develop applications. So we're certainly moving a lot of our teams from more kind of historically hardware-centric design focus to more software and usability focus. So I think the same is true probably in the industry in general, but also with our customers to put a lot of focus around software engineering.
That's very interesting. I didn't know that. So NXP has more software engineers than hardware engineers. So Marcelino, what do you think?
So I fully concur with Justin on the fact that the amount of software is increasing. However, the customers tend to want to buy hardware. They're not willing to pay for software. How do you even monetize it? How do you buy? So you're forced to bundle it, but then you cannot. It's extremely hard to have a license paid for software that is running exclusively in your component. That at least is a challenge for us, and there is a growing amount of software. To your point, also on the MEMS sensor side, a significant portion of our R&D are software developers, right? And yet it's so difficult to monetize. Another trend that we're seeing, to your first question, is the fact that as an industry, we are disaggregating what has been aggregated in the last 10, 15 years. Now, geographical aggregation, value chain aggregation, and this feels a bit of a constraint, right, on one side, but that's where, maybe we can talk about it later when we talk about the CHIPS Act, whether this is helping or not. So a kind of disaggregation of the value chain is something that is creeping up, and let's see, this is a trend that we all have to deal with.
Got it. Thank you. That's really, really insightful. And Vincent, what do you think? You see all manufacturers, all sensors, you sit right between the customers and a lot of us who are building hardware. So what are your thoughts?
Yeah, sure. Thank you. And we do. The interesting thing is, as a distributor, we don't manufacture, right? So we represent the top suppliers and the manufacturers, and we bring those products to market and bring them to our customers. And ultimately, the customers are looking to complete their end product, right? And so part of what we're faced with is a little different. I mean, certainly software is key, and we see that creeping into the business more and more, and it has become more prevalent. But for us, one of the biggest challenges that we're dealing with is, currently is the geopolitical and socio-political economics and the world around us, because it's creating this fragility that everyone is a little bit concerned about, we're hesitant, we're unsure about. And I think part of that is helping to drive, I think someone said, the inventory, or, Ganeet, you mentioned something about the inventory. We look at it as, perhaps as an inventory imbalance right now, and we're trying to work through that. So, from our side, I think there are a lot of things that we can do and we need to do. And if we think about the CHIPS Act and science and technology, that's a great start. And I know we'll talk a little bit more about that, but I think that's a big piece for us.
You got it. You're a moderator's dream. You just took me right into the CHIPS Act and into the government policy. Let's talk about that. So, of course, I don't know how many countless people have canceled their vacations abroad because of geopolitical, and they're actually vacationing in the US, and there's a lot of movement to just ensure, coming nearshoring. So Justin, why don't you start? What do you think of the government policies, CHIPS Act, infrastructure bill? Like, are we doing enough? Like, how are we doing?
Yeah. I mean, maybe not exactly, the CHIPS Act is maybe not my specialty, but one thing I have seen over the last couple of years, and I guess it's related to some of the policy and some of, the outcome or the reflection from COVID, is just I would say a real appreciation, or a much deeper appreciation to our industry and the real complexity to manufacture electronic components and to build an embedded system. And I mean, I think you all know how complicated it is to build the products that you build. It's extremely challenging for a manufacturer to build some of these breakthrough products. It takes us months and even up to a year to build a product, and I don't think that was really well appreciated during some of the prior years. But during this, the past few years, there's a lot more, I would say, appreciation to understand how complex the supply chain it is and how important it is to understand the dynamics in the industry, working with distribution partners, looking at the lead time of components, preparing with your partners on the bill of materials, and so I think for me, one big shift, like mindset shift in the market, in the industry, is more of a realization around the complexity of the supply chain. And,
interesting.
And for me, that's a really critical part of how we go forward together with our partners.
And the complexity of the supply chain, do you think is, in the current, I guess, whatever we're doing in the US, is it conducive to making that helpful to get resolved, do you think? Or we're on our own as an industry and the government's not really helping?
Well, I mean, I'm based in Austin. We have 2 factories in Austin that build our microcontrollers. We partner with companies around the world to build more, but so there's a significant amount of focus from our teams about expanding the capacity we have in Austin. We're bringing some of our microcontrollers that we built overseas, into Austin, both for redundancy for our customers, but also for increased capacity. And so,
Yep.
There's a huge amount of pride and attention with our engineers and technicians in the factory to, be able to build more and more products in Austin.
That makes
and I think our teams are excited about the opportunity to keep building more products.
Got it.
In our factories. So.
Thank you, that's really helpful. And what does an Italian working for a German company living in Sunnyvale think about it?
Well, again, let's start to understand first where we're coming from, right? We are all also consumers of electronics. And there's one thing we all want is that whatever we keep in our pocket, have on our desk, whether it's a laptop, on a tablet, or a smartphone, what is it that we want? We want that every generation, every subsequent generation is more powerful in terms of computing, with more features, with less price. Therefore, how has the industry adapted to it over the last 10, 15, 20 years, right? It has created consolidation, and a consolidation that now we come to think that it's not healthy, right? To your point. Consolidation that most of the front-end manufacturing is done in Taiwan, most of the back-end manufacturing is done in Korea. This has been perceived by the world as too fragile, and we have seen it during the component shortage. Now, the CHIPS Act has been designed to address this, and there's not just one CHIPS Act, right? With my multi hats, I can also think about the equivalent of the CHIPS Act that's happening in Europe.
Yep.
But if you add up the amount of money and the amount of incentives that are generated by CHIPS Act in US, plus CHIPS Act in Europe, you are still less than the equivalent incentives that are in South Korea.
Yep.
So South Korea alone trumps the sum of US and Europe. So will this help us to get out of this consolidation? I don't know. For sure, it will create more capacity. For sure, it will create more fabs. Will this overcapacity then result in what we as customers want, which is, again, a lower priced, higher performing gadget that we keep in our pocket? That I'm still not entirely sure. But there will be a wider disaggregation of something that has been aggregated in the past.
And free software. So you want
and free software.
You don't want
of
software.
course, and free software. Open source.
Yeah, that's right. That's very fair. I think it's a step in the right direction is what I'm hearing, but not enough. Or we need to think about doing more, right? Because just from a volume perspective, what we're doing is not equivalent to what's going on in Far East, right? Yeah. Vincent, what do you think? Is that right?
Yeah, I think he's spot on with it. And Marcelino, I appreciate you saying that, because one of the things that we noticed is if you look at in the US, the Chips and Science Act is roughly $52 billion that has been designated, right, for the investment, and of that we're only talking about 39 billion or so that will go into the fabs and the front end. The issue that you have is that again, there are other countries and other regions where they're investing a whole lot more. And to that point, if you think about after the CHIPS Act was signed late last year, it was, I believe, Intel and Micron both announced that they were investing somewhat in the neighborhood of 24, 25 billion each, or I believe it was 20 billion each. It was the exact number, but essentially more than we've done anyway. So we do need to do a lot more. It's a great start. I shouldn't say it's a great start. It's a good start. We need to do more to help drive the not only the infrastructure and the process, but really think about it from an end-to-end solution, if you will. And I want to just highlight one thing that we think is a big gap as far as the CHIPS Act. If you think about where the money is going from a semiconductor standpoint, it's primarily front end. It's on the fabs. But that doesn't address the full problem, right? So when you think about where we are from a back end, OSAT and packaging and test, we're going to be in a world of hurt. A lot of that, roughly 70 to 72% of the back end capacity is in Asia and in primarily between China and Taiwan. So we are still at a risk, whether it's in the U.S. or Europe or elsewhere. We as a global country or a global economy, we're still dependent upon that one region, and that's not good. So I think we need to do more in that back end area.
Yeah, I can't agree with you more. I think it's a baby step, is what I'd call it. It's a step in the right direction, but when the entire act is less than 1 year of the budget of TSMC, one company, I don't know if it's enough. So I think that's
exactly.
The other part of the CHIPS Act, or everything the government is doing, I think is very fascinating. There is, of course, a spend, which I appreciate you saying is more front end, which is a problem. But there's also a focus on the talent. And as Arduino, we're very, very passionate about that. I mean, our founder, Massimo Banzi, and team, they started the company focused on learning and education and the new ways to do software and the new ways to do electronics combined with software, which, you said both of you have more software engineers than hardware engineers in your companies. But maybe let's talk about that a little bit, because, what do we think of the talent which is available today? Europe has done a really good job at polytechnics and having a lot of talent base, maybe not as much in the US. But I think CHIPS Act is, or just in general, government is trying to address that. But I'd love to get your perspective on, what do you guys think? Anybody, we don't need to go one-on-one.
I mean, I'm personally, we can maybe bounce around. I'm personally extremely excited about the future. I feel like innovation is what helps shape America, and the number of I get to meet a lot of customers around the world, and especially in the United States, and there is so much exciting stuff happening. There's so much innovation that I think engineers across America are going to come up with new ideas and new ways of solving problems. I think that's what formed the industry previously, and that's what's going to take us with some new technologies into the future. But just to give an example, I mean, for NXP, every summer we bring all of, maybe not all, but we bring a ton of students into our campus, and we do a whole bunch of science and technology and enrichment programs, even down to elementary school and middle school. But we focus on helping give back to the community, and I think there's a lot of companies in the United States that are doing that, and so that makes me really excited for what will come in the future. So I think the policy is going to certainly help, and the focus around that. But I think it's about getting young students excited about technology, in new ways, and seeing how that can impact the future of our lives.
Yeah, absolutely. Yeah. What do you guys think?
Yeah, and definitely talent. We, as Bosch, on a worldwide basis, we have this very strong internship program, right? That both allows for students to come into Bosch, but at the same time we have some adjunct professors at different universities. We have a couple at CMU, we have a couple in the Boston area, we have one here in Silicon Valley. So, and this kind of it also brings a draw. But going back, if I may, to the effectiveness of the CHIPS Act investment on the hardware side, can I do a little poll?
Yeah, sure.
Okay, so I like, with a raise of hands, I like to know, to see how many people were directly or whose company was affected by the component shortage. Okay, quite a lot of companies. Now, the second question is, of the people who, of the companies who have had component shortages, how many of these components were coming from high technology nodes? I'm talking about the deep submicron, high integration, deep VLSI chips. I'm talking about, the 12 nanometers and below. How many?
Wow.
Okay, so let me turn the question around. Of the people who have been affected by the component shortage, how many were from older processes like power, like MEMS, like more traditional technologies? Raise of hands.
Yeah.
Okay.
Yeah.
This is
fascinating.
This is fascinating.
Just, you guys didn't look at it. A lot of hands went on component shortage. 0 hand went up on the high tech, and then 50% or so hands went up in the last question. So that's
and guess what? The CHIPS Act is investing in what?
Yeah.
Yeah.
Right?
That's a good point.
It's invested in deep submicron.
Exactly.
And so I'm scared. I'm scared about this. There is a dissonance, right? And okay, this is a sample properly of sensor-minded people, right? Maybe if we went to a Qualcomm conference, maybe it would, or an Intel conference, we might get a slightly different result. But I'm not so sure, right? I'm not so sure. I mean, Arduino, were you affected by shortage?
Yeah, of course.
From traditional, from older technology nodes?
Yes.
Bosch
Yes,
the
yes,
same.
yes.
Bosch the same. So,
Yeah.
And for us, I mean, because again, we're a distributor, so we saw it across the board, and so we were involved in constant. So we look at pretty much the constant expedites and the shortages across all of the technologies, but there's a ripple effect that we see and probably others as well. But I think going back to the comment, I mentioned before about the back-end processes, that's the one piece. The second piece, Marcelino, is exactly what you mentioned, that we're investing money in the bleeding edge and the leading edge, call it the 10, the 7 nanometer and below. And it's really that 28 nanometer and higher, the legacy, the more mature products that we need and that we're going to need. Because when you think about what the market is driving and the technology is driving, we're driving that faster, cheaper, right, better, and part of that really drives the end applications around the industrial sector. And when we think about IoT, that's an area that's going to rely heavily on the mature and the legacy products that we're not investing in. So we're still going to be short there.
Yep. No, that's fascinating, and it's a really good point. And this is perfect because now we can go off script.
But it is
all
true.
the questions changed.
I mean, even on the microcontrollers, really, I mean, I would say the bulk of the volume, just in general in the industry, is probably more 90 nanometer to quarter micron. Really, I mean, just now people are starting to really embrace 40 nanometer based embedded flash MCUs. So I think the majority, if from an MCU perspective, I would imagine a lot of the shortages would have probably been microcontrollers that were built 10 to 20 years ago, actually.
For sure.
Yeah, and that's a really good point. So I think my next question is really a lot of us here are, of course, building sensors, of course, building applications specifically to get the sensors to drive business value. But a lot of us are smaller companies, right? Without that much, I guess, negotiation power or whatever you call it from a supply chain perspective. How should we think about it? Like, what advice should you give to smaller companies or startups here who are in this space on? There are shortages, there are some things going on in the policy. Like, what are the ways we should think of just being better at our own supply chain resilience, or getting the products out there so we can make some revenues and revenue targets? So any advice or any guidance?
I'd be happy to jump in. I don't want to monopolize the conversation, but again, because of our business and because of being in global distribution, that's really a sweet spot for us. If you think about, and I'll talk a little bit about supply chain, if I may. I think COVID brought the supply chain lexicon really to the forefront, and people at that point didn't know the difference between, let's say, blockchain, supply chain, or a gold chain. And maybe today they still don't, but they know that word has been overused. And if you go to the Lake Superior State University, you may not know who they are, but they're the organization that defines those words that should be banned from our language. And of course, supply chain is one of those, and that was from 2022. But thinking about supply chain, I think many people think back just to COVID as that's kind of the genesis of it. But the reality is it's core to our business and it's core to the electronics industry because the long time it takes to manufacture. If you look at what it takes to manufacture a chip and a high technology chip, you're talking months and as Justin mentioned, even over a year. So you really have to think about that from start to finish and how important supply chain is. If you go back a number of years, and I mentioned COVID as the most recent, but if you go back, think about, I'm sure many of you would be familiar with the volcano in 2010 over Iceland, right? That basically shut down the European airspace. And that is like all of a sudden the supply chain, came to a grinding halt, and that was one of the first things that people experienced. But it lasted through the summer of 2010, and then kind of went out of people's minds. The following year in 2011, I believe it was, we had the earthquake and tsunami in Japan, right, with the shutdown of 3 nuclear reactors in Fukushima, and so we had more of that. And following that, we had the flooding in Thailand that impacted the hard drives and storage. So that my point is, we've had these kind of starts and come back and restart, and thinking about the supply chain, it just becomes more and more prevalent. But from a distribution standpoint, we've been involved in it since literally the past 30 years. We had a division called Avnet Integrated Material Services, and we still have that essential business, but supply chain is a critical piece. And I think if anything we've learned over the last number of years is that we can't do things the same and expect different results. So we have to improve that supply chain. We have to become more resilient, and that's an area where we help a lot of the smaller companies that are out there, because they don't have that vast network. But we can certainly help to aggregate demand from a supplier standpoint, from a manufacturer standpoint, and provide that logistics and delivery solutions that are otherwise not available. So I think from that standpoint, that's an area where we can help at, and obviously the planning piece becomes a big part of it from a manufacturing standpoint as well.
Yeah,
I can jump in. I think at NXP, for the last 15 years or so, I've been doing, in some way, shape, or form, engaging with smaller companies. And for us, we call it the industrial multi-market. But there's lots of different ways of segmenting that part of the market. But that's really become my focus over the last 15 years. And one thing I've really seen during the last 3 years, and just building off your point, is a little bit of a historical way of looking at things more transactional, and just working with whomever had inventory and buying parts, and not building relationships the way that you really need to, in my opinion, build relationships with the distributor, for example. And I've seen so many customers, I've met with so many people over the last few years, they were just looking to buy from whomever had parts. And what happens is, as a manufacturer, you have no way to bring visibility and understand what do they really need. And even large companies, they'll source components for the same part across the world, as opposed to really bringing a more strategic sourcing perspective with a strategic alignment with the distributor of whomever their choice. The other kind of flip side of it, I've also seen a major challenge with small companies to figure out how to manage your bill of materials. And so, companies are trying to figure out, how do I get this part, this part, this part, this part? And the lead times are all different. And you have to source from so many different places. And so one thing I've seen over the last few years, both in terms of investment with private equity, but also new companies coming up, is building modules and system on modules, and taking these components together and bringing that to market. And so then, small companies don't need to buy so many piece parts. You can work with a partner that can then do a little bit of the aggregation. So I've seen both of these two things really, come more to the forefront with a lot of companies.
very interesting. Marcelino, any thoughts?
There's a semiconductor curse, right? If you're a semiconductor manufacturer and you have a semiconductor fab, right? If you're fabless, but if you have a fab, you want to keep the fab at 100% utilization. If the utilization goes down to just at 70%, already your cost of goods is more than doubled.
Yep.
So you essentially cannot sell the part. You cannot sell the part. So you're always living on this thin edge, and this is true for pretty much any process node, any any product line. You're always living in that thin edge. And again, as consumers, you cannot afford to double the price if the volume goes down. So how do? You always right size. So you cannot upsize, you cannot downsize. You need to right size your fab that is built maybe 5-10 years ahead of when the peak will be, and so it's a curse, right?
Yeah,
it's a curse.
It's interesting. So I heard some really interesting, and we'll open it up to the audience in a minute. It's very interesting to see, what you guys are talking about, strategic relationships, sourcing, right sizing, as well as looking at more modules and components versus individual components. Just one, 2 cents to add from our perspective as Arduino is hardware abstraction. A lot of this can be actually done with a software layer where you can actually have a little bit more independence on hardware components, as well as having different kinds of hardware architectures. And if you could do that, a little bit more in the software layer, and both of you said there's a lot of software and software engineering happening there. That's just one more tidbit to add from our perspective. We love advising startups to say, hey, have an architecture which allows you that flexibility of if this 2 components are not available versus something else, that you can actually look at that as a more strategic way of getting to market. And accelerating a time to market versus waiting. So in addition to everything that you guys are saying, I think we've seen that. So with that, let's open it up. It's a great time to open it up for questions with the audience, if anybody has any. I don't know if you have a mic, but we'll start there and then we go there. Right behind you, right behind you. Sorry.
I don't want to stump the teacher, but 21 years ago in ISSCC, there was a discussion that this discussion will happen in 20 years, that we're going to have a shortage of the chip, shortage of components if we ship everything out of the country. And there were a couple of guys from DOD and State Department and a few other people on the panel, about maybe 3,000 people in the audience, and I'm there listening. 20 years from now, what are we talking about?
Crystal ball time, guys. 20 years from now.
It doesn't sound like we have moved much, right? And you telling me you're scared. Yeah, we're going to put in money in the 5 nanometer that we can't use it for anything, really, or 10 nanometer. And we're forgetting about the chips that goes in a car and probably around 3 micron. I don't know. But what are we talking about 20 years from now, in your opinion?
So let me, if I may, let me soften up the pill here a little bit. So there is a need for 5 nanometer and below, right? So there's no question about that. And those are the kind of fabs that need the biggest amount of funding because of, if you just break down the economics of the capital investment that's needed, it's phenomenal. So that's where you need the greatest help, just simply to catch up. So that said, right, we need to make sure that we guarantee. I mean, there's a few trends that we're talking about. Yes, software, but electrification. Right? Electrification brings us to the need for components such as silicon carbide components, right, for power electronics. Those are not deep submicron. Do they need new fabs? Yes. Do they benefit from some investments? Yes, maybe not as many. So maybe a fab for silicon carbide will cost less than a fab for a 3 nanometer process. So that helps a little bit. Now, but if I still look at my crystal ball in 10 years from now, I am personally a little bit scared that there is going to be an overcapacity somewhere, right? And that prices might not go down as quickly as they used to. And we have to be ready as consumers. And we're already seeing, my advice is anyone who makes a business plan, who has made a business plan in the last 20 years, has always left the Excel sheet out when it comes to inflation. Inflation was always 0, so you kind of ignored, for your net present value, for your forecasted sales, and so on. Now you have to add, an inflation or a price increase row in your Excel planning that takes into account that there could be some variations in prices, both as incoming and for prices for the components sold. So that's inevitable. What that means as consumers, will this drive consumer consumption of electronics down? That is very hard for me to tell.
Pretty fair. One more question over here.
No, it didn't start yet.
I know, but I'm saying this is the spot, right? Okay. I guess tables later.
Yes, thanks. What's the rapid and accelerated adoption of AI, what's that going to mean to semiconductors, sensors, even IoT? How's it going to impact that?
From my perspective, I think that's really going to reshape. I mean, I think everybody talks about AI. You don't see a press release or anything in the news without AI. I think, every article I read about in our industry, AI is in the title, and obviously it's a big hype. But frankly, I really think that's going to have a huge impact on our industry in general over the next 10, 20 years. I think combining sensors, connectivity, microcontrollers together in a very efficient way and getting all this intelligent data from around the environment is to me, and you put machine learning algorithms on top of it, I think it's going to have a huge impact on how we interact with the world around us. I don't even think, right now the machine learning is really just in the cloud, and there's a significant amount of investment happening there. What NXP is doing is taking AI to the edge. And I think once AI comes down to the edge and it becomes more mainstream, which is really where we as a company is focused, whether it be in the car or in a factory, I think it's going to open up a whole range of possibilities that people could never imagine today. And to me, it's about data, and you can't get data without a sensor, and you can't perform machine learning at the edge without the processor. So it's going to be, how do you connect all this together, and what are the new possibilities that people never dreamed up? And I think it's going to really reshape the industry over the next 2 decades.
Yeah, and if I may add, I think it's a no-brainer, but I was on an AI conference last week, and everybody talked about how data, or capturing the data and the right data, and the concern with the compute is why the entire AI and machine learning world thinks about not making it to where they want to make it. So really, data and compute are the 2 biggest issues. I mean, I don't know if you guys knew this, but more than 1.3 million, I think the number was quoted, was daily spent just to run ChatGPT infrastructure. Right? Think of it as like more than $1 million a day just to run the text engine predictor, if you may, of the world. So I think there is no, to answer your question, I don't think there's any way out for us to not think about AI.
Yeah.
Because we're seeing AI in screws and bolts now going in. So I think AI will have to become a part of our sensor life, and we'll have to figure out how we kind of get it down to that level. I don't know, Marcelino or Vincent, if you guys have any thoughts.
If I could jump in, I mean, I think Justin, you're absolutely right. It's going to help. AI is no doubt is going to help drive component demand and particular sensors. So from my standpoint, I'm really excited about that. From an IoT perspective, AI moving it to the edge, that makes that data that much more valuable. In fact, here we did not have a booth here, but we did a workshop, a hands-on workshop that was around AI at the edge and the Raisin board. So I think there's a great opportunity for us, and I think I would tie it back to, Marcelino, your concern over the next 10 years is we're going to have oversupply. I think this is going to consume all of that oversupply, right? AI and all of the all of the data requirements around it. I'm hopeful that it will. So
10 years from now, we'll sit here and see who buys who beers.
Exactly.
So, yes.
Exactly. And I think with AI too, there's just so much that we don't know yet, right? There's things that we haven't even contemplated that will, become evident over the next number of months and years. And again, hopefully in that 10-year period, it's going to just suck everything up that we can possibly make.
Yeah, when I think about AI, I mean, you just come to our booth. There is not a single sensor that doesn't process the sensor data locally. There's not a single one. So we call this, processing on the edge. Is it artificial intelligence? I don't know. Some of it is, right? Some of it there is machine learning. Some of it is other kinds of processing. In general, I'm not scared about AI. AI is a great opportunity. I'm more scared about HS, human stupidity. Right? As opposed to artificial intelligence. And because in order to make AI work, you need to have the human in the loop. And that is what keeps AI tangible, usable, ethical, and really helping your life. So that is my only concern.
That makes total sense. Guys, this is a fascinating discussion. That clock is turning red for whatever reason. I don't know why, but I think we have to wrap up. But thank you so much. This is fascinating. I really appreciate you guys making the time. We heard everything from software engineers, more software engineers on NXP and Bosch, which I did not know, all the way from what the government is doing and how we can kind of help each other out, all the way to some advice to smaller companies, and then the crystal ball. So we'll see if Vincent is right or Marcelino is right. So, either way, Justin and I will be here to, drink those beers that you guys buy. So thank you guys. Thank you everybody for coming in, and appreciate it. Thank you.
Thank you.
Thank you.